talking. I'm just here because he doesn't know how to run a computer. All righty. Let's see here. And actually, I probably should have done this first, right?
Hey. Hello, hello, test.
So as you can see, Flutter makes them easy. My name is Scott Stoll. Don't let the accent fool you, I'm a Yank. So there's one thing I found out already. In America, we have the food before the meeting and the alcohol afterwards, and I think I like your way better. But I've been doing Flutter for about a month. It's a career change. No, about a year. It was a career change. I've been doing troubleshooting and hardware repair, starting with electronics and a lot of other types for about 25 years. Needed a career change because I started having a bunch of ligaments and tendons go out. I can't keep, doing stuff with machinery. So fortunately, I had the luxury of time and put some time into learning Flutter, and here I am.
I'm Simon. I think I know most of you from online places, and that just, yeah.
I didn't think you guys were real. I thought you were just a bunch of icons on my computer.
Yeah. And well, I've been doing Android now for about 10 years, and last year I was at Google's offices for a presentation, and Whelm Lima did this brilliant talk on Flutter, and it really sort of stuck. I was like, this is kind of what we've been looking for in the mobile dev area. And since last October to now, I've just been making Flutter apps full time. So we're going to show you some cool, hopefully some cool, wicked animations. And yeah, well, let's get started.
Okay, and one last thing. Actually, I know all you guys have got those Flutter stickers. They're common, but I've got GDG Cleveland stickers. No, but actually what happened is I got the OK from Cuba to start GDG Cleveland last month. We just had our first meeting, and the really interesting thing is that when we were in the meeting and she said, go ahead and start the group, 4 minutes later she asked me if I could do a dev fest. I've had the group for 4 minutes. Anyway, moving on. Difficulty level. This is intermediate. We're assuming that you've heard of Flutter. Probably a good idea. You understand the basic concepts of animation. You've done the basic tutorials. How many of you guys consider yourselves like an expert on Flutter? You know it pretty well. Brian, leave. Go. If I screw something up, I don't want you pointing it out and making me look bad. But no. OK, so intermediate, it's not beginner. So doing this in Android. Simon, how would you do this in Android?
So I think if any of you have done any Android development, you might have seen some of these lovely transitions that you want to be able to do, and found out that trying to do activity transitions, well, you're hitting your head against the desk, and trying to do fragment transitions, and you're hitting your head against the desk. And in fact, if you're trying to do any animations in Android, you're pretty much hitting your head against the desk. There's just, at some point, that you need to say no, especially when it comes to backwards compatibility on Android. We're not here to really talk about Android, but I do need to make this clear. There's about four different animation frameworks off the top of my head that Android has. And each one was added to the framework after the previous. So if you want to have any backwards compatibility, you need to use the least capable version. And that means you kind of lose all that nice functionality to do these lovely transitions that you want to be able to do. So with Flutter, the fact that it does all of the rendering itself, we have the benefit. We have the tools. We have the technology. And we can actually do these lovely transitions. And these, the one on the left here is from the gallery app, I believe. Mm-hmm. So we're going to try and show you how to do some of these things.
Okay. Now, this is our inspiration. If you take a look, I will put this on loop here in a moment. It might take me a minute to figure out how to put it on loop without a mouse. There we go. OK. Now, another thing, too, that's I'm going to slow it down. That would be the other thing, too. We're going to run half speed and see if that's slow enough. So when we get back around to the beginning, when it opens up here in just a couple, you're going to notice there's an what we're calling an accordion appearance. Comes in, and then the bottom comes in slower than the top. It's going to take quite a while now that we've slowed it down.
There we go.
There it is. So you see the evening with cardio went in first.
There's a hero animation.
Route animation with a hero, and then there's a delayed fade in. And see, this is where I'm going to cheat. Okay. What this is doing now, we're going to leave one of these pieces for you to do. Okay, it's kind of like a homework assignment. You see right here, evening with cardio session. It heroes in right there. To the next page, you guys are going to do that. Okay, so we're going to turn it into a little bit of a code lab. Now, it comes in, and there's a delayed fade in here on the bottom. Sorry. Now we get the button size right here. You'll notice that this button is on page 2 and 3. It animates, and it stays there. So that's an interesting little thing. Keep one element on both pages. And the way that we're looking at approaching this right here is with just the cheap way. Use a stack. Put the little background elements here in place. Use a little translucency in the second layer, and then our little items here on the top. So, oh look, YouTube took over my screen.
So, core animation classes. This was stolen with permission by Nitya. I don't know if any of you have played around with the animation framework, but you actually, the animations need to be in sync with the screen. So the first thing that actually comes in on the left-hand side here is the ticker provider. Every animation controller requires a ticker provider, and there's a couple of mix-ins that you can use. The most common of which is single ticker provider mix-in, I think it is, and you'll see that coming up in some of the code. On top of that, so the controller is there just to provide a lower and upper bound. This is just to give a value to be changed over the duration of the animation. There's no actual values other than that double value being changed. So if you want to animate anything like colors or rectangles or padding or all that kind of fun stuff, you end up using a tween, and on top of that you can end up using curves, which allow us to, rather than just do a standard linear transition from one value to another, we can actually do these lovely ease in, ease out decelerations and all that fun stuff.
Okay, and does anybody feel that they would benefit from hearing it in a different way? Because when I'm teaching, one of the things that I've always learned is if I hear it from multiple people, usually the last one will cause my light bulb to go on. But if you guys all have already got this, then let's not waste time with that. We're good? We're good. Move on.
So you might have seen this. This is kind of like the very, very basic animation controller setup. You give it a duration. And the key thing to remember is vsync.this. This is to say that use the current widget normally when you use this for the synchronization with the vertical sync of the screen. This is about the fact that single tick provider is essentially a provider for a ticker, and that is where the framework will go ahead and link up the synchronization of the screen to the animation controller itself, giving your animation a chance to build each frame of animation.
Now, animation types. We have tweens. A tween has a duration. It also has a marked beginning and end. And the interesting thing is that the beginning and end do not have to be limited to the I'm sorry, they don't have to be pinned to the duration. If you take a look at a couple of them, there are a number of them out there I've seen where the duration is 2,000 milliseconds, yet the beginning is at 1 and the end is at 1,000. So you're not chained to ending your animation at the end of the duration. They can be linear, they can have curves. There are lots of really cool curves built in. As you can see, oh, I turned to the right and the mic went. How's that? You were right, George. This one eases in and out. Okay, this is elastic in. The other interesting thing is that since these can be played forward or backward, okay, you can also just use reverse. You can do animation controller.reverse without doing forward, which means now you're elastic out. So you're not stuck with just one. We have a bounce in, reverse it for a bounce out. There we go. But of course, you can use the actual bounce out. Now, that didn't work. That works. You can tween a lot of things. Okay, you can tween box constraints. You can tween decorations, which means you can tween your background images in your containers. You can tween your edge insets, your margins. Matrix 4 tween. You can tween Neo. You can tween your text styles. I hadn't even thought about that until this afternoon when we were looking at some stuff, and then I rammed that in here.
It's worth investigating the platform widgets because a lot of these are actually used to do some of the things that you might have commonly seen from the material widgets, such as the collapsing header, when you have the large font text going down to the small font text. That is a text style tween.
And another thought like that, too, is tie in. Now, a lot of you guys have played with animations. You know you can animate multiple things simultaneously off of a single controller. So animate the location of your text and its text style simultaneously and watch it morph as it moves. You can do a lot of things playing around with this. Now, we also have physics animations. They can be any function at all. They can model real-world behavior. They don't have to have a beginning and end. There are several built-in simulations already. Some of these I didn't even know about until I started researching this. Bouncing scroll, clamped, okay, a friction simulation, gravity. A lot of people have seen the spring one. So, and there's also a fling one that's not listed there. Spring and fling are some of the more popular ones. So the animated switcher is a little bit more complicated, so I need a real geek for this.
Thanks.
That's your cue.
So if you guys haven't tried the animated switcher widget, I highly recommend it. It's one of those little known widgets that we can go into the sort of details of this, but to be honest, all you need to do is switch out the child widget. You switch out the child widget, it will keep the old widget around for the duration of the transition. So you immediately get implicit animations of any widgets. Very, very, very powerful. However, what we've got here in the red text, if you try to give it a new child of the same type as the old one, it will not transition them since it thinks they're the same. This is about the way that the framework matches the previous element that is under the system for the previous widget that was displayed on the screen. And it will think it's exactly the same widget even though the contents has changed. So you need to make sure that you specify a key, a unique key. This can be a value key. It doesn't have to be a global key. So this is just to make sure that it identifies it as being a separate widget instance, and then it will animate and nicely transition between the two. Animated builder is another one. This is probably the more common one that everyone's seen. It is really, really powerful, actually. So just want to explain some of the principles. So first of all, the animation parameter here is any listenable. And when I say any listenable, that is a scroll controller. What's the other one? Paging controller. All of these things notify of their state change and are in fact listenable, which means you can have your widgets rebuild themselves when scroll changes, which is one of those nice powerful things that you can end up doing when you want to have these nice scrolling effects. Builder is run every time the animation parameter changes or notifies that it's been changed. The child, however, is only built the first time the animation widget itself is built. So this means that in this situation, we're going to rotate the container widget here, this green box, but the actual widgets, when they get rebuilt, the green box stays. It's the same widget, it doesn't get reconstructed, doesn't get rebuilt, only the surrounding transform.rotate here changes and gets rebuilt. And this is because it passes in the child parameter, and we use that as our child for our widget.
So the container and the box never actually change, it's just the transform.
Yep. Yep. Okay. Modal root animations. This is the fun stuff. So you've all probably used material page root, hopefully. That's like the default that everyone goes to when doing a root to load some new content on the screen. Modal root. Well, sorry, before I go on, let's talk about root transitions. So internally, the way they actually work, the transitions for the roots are actually the same as animated builder. The content is only built the first time the page is built, and there's a separate build transition method, which is called each time the state of the root changes, i.e. pushed or popped. Otherwise, it continues to use the existing element on the screen. This is kind of critical because you get given the animation element. It doesn't call the build function for every animation frame. It only calls it when pushed or popped once. And that's enough for you to set up your animations for your transitions. Excuse the time.
Let me fix that.
Modal root. So if you don't know, material page root extends a page root. Page root extends a transition root, and then transition root extends a modal root, and finally that extends, I think, a root underneath that. So basically, any of the pop-up root or page roots, which are the standard that everyone uses, all exist underneath as a modal root. In short. Sorry.
We never went back to spell check. We will be putting this whole slide set up. I'll get a shareable link after I fix this. He's dictating, and I'm sitting there touch typing without looking, and never mind. Next. Oh, wait, were we done?
Yeah.
Well, we got to talk about the cows.
As you all are probably aware, that there's a pattern that's common in Flutter when you're going to use inherited widgets, and that is to use the .of syntax. So it's theme.of, media query.of, and so on and so forth. There's also a modal root .of. This is the key concept behind root animations. Once you do modal root of context, you'll get a animation parameter from that, and you can use that as the parent to all of your other animations. So basically, as the page transitions, as your root transitions in, you can do all these wonderful transitions in the contents of your root as it transitions into the screen. I think I'm kind of... hang on.
You ruined it.
Oh, and sorry, one of the points here. Check the status of the root animation. So this, you can say, once the root animation has completed, this is when you know that your root has finished transitioning into the screen. Then you can then start more animations from that point. So there's, we'll talk about some key points in the original animation, the original concept, should I say, that cover these things as we go.
Now?
Yeah, go for it.
Are you sure?
So I
like
was
a
racing
train
to
wreck.
complete some code, so hopefully we'll get there.
George, that's not the slide you should be photographing. All right. Let me split this screen so that you guys don't see what I see, so I can fix some typos while he's doing this now. Okay, this actually will just take a moment. You've got to be kidding me. Close enough.
Windows key and left, and then Windows key and right, and then adjust the size.
That'll do. So we'll take you through. We've actually got an entire application here. So it's not quite example this, example Y. What we'll be doing is finishing this off, and it's already on GitHub. We'll give you the URL, and we'll be finishing some of the nice animations off and making sure that you all have access to it. So let's go from the very beginning. Main.dart.
Okay. Where did you hide it? No, kidding.
There you are. That's how every main.dart should look. No, seriously. Do not put any code, any widgets in your main.dart. I do want to cover this point. This is kind of off from animations, but the main file is imported differently to all your other imports, and it means that you will have type collisions. And this is, you might have experienced this if you've ever tried to use inherited widget and use main.dart for your inherited widget class, because it won't work. So I warned you. Okay. Again, standard stuff, nothing magical here. Material app, theme, and home screen.
Sorry. The touchpad's a little rough, so I'm going to do something about that here in a moment.
So this is the outline for, can everyone see that code all right, or should we make it bigger? All right.
Bigger?
So we've actually done a couple of interesting things here.
Okay.
We'll start from the top and work our way down. I don't really want to cover it in too much detail, but there's some interesting points that we might as well cover while we're here. You've got wheel pop scope and navigator. If you've ever tried to do navigation of routes inside your app, inside a small portion of your app, you need to implement a navigator. And if you want to handle back, you need to implement wheel pop scope. And you basically create your own key, and you use that for your navigator, and then you use that for wheel pop scope. And there's this little tricky async not await, which you copy and paste this, but basically that allows it to pop and return a asynchronous boolean back to this pop scope. So fun stuff.
You want a mouse?
Yeah, sure.
I just put it on the paper.
That's all right. So we've actually decided to do because the bottom nav here behaves slightly differently. It's more like an iOS bottom nav. We've decided to get rid of the bottom navigation bar and not use the material one and use a custom one. Again, most apps you end up wanting to do some sort of custom navigation. So this is a good example of how to do that. So down here we've basically got, I'll skip down, navigation bar widget. This, you provide your items. Items is just a standard class. We've got down here at the bottom. We specify an icon and a label, standard stuff. And the navigation bar itself, you give those items and on item selected, which is how we're going to get notified about which tab was chosen. It maintains its own state. This is, again, a kind of an interesting point. Whenever you use bottom navigation bar, you end up rebuilding the entire scaffold and all of the content because it doesn't maintain its own state. So by doing this, we guarantee that when you change tabs at the bottom, only the tab bar itself is rebuilt and not the rest of the app.
Okay.
We're actually wrapping a bottom app bar, which is one of those newer widgets from the framework. And if you're ever trying to work out how you actually get your theme to theme the icons and the text properly, you use a default text style.merge and an icon theme as well. And we're getting the primary icon theme. These are generated for us by the theming framework. Primary icon theme is one of those things you can specify manually, but what's quite nice.
What you're talking about, the red button.
Hello, there you go. Primary icon theme is quite handy. It's built into the framework for us. It will take the primary color you give it and give you the opposing contrasting white color or red color or whatever it might be that's opposite to the main primary color. And here we just build a row, and we do this list generate with the items that we've been given and build each one. This is so we have the index. When you do a map, you only get the item and not the index for that item. So this is required. And then what do we have here? Navigation item. So again, we're just fetching the item for that index and then building up the icon you see down here and the text above each other. Nice and simple. If it's the selected item, and we get the current theme and wrap it in that default text down icon theme to give us the accented color. And then we give ourselves an ink response. We do expand on every one of them, so they all take up an equal amount of space. And if we specify on item selected, then we manage our own state. So we set our selected item and then call the callback. And we're going to take us back up. This is actually the callback that's passed in. And this is where we're going to work out what route to show. Since we only have a route for the main workout page, we have a blank one and a workout list page. And we just manually work out which route it is, and then pushing that as a replacement inside our internal navigator. So not the navigator that surrounds the entire app that's built for us, but our own one that we've added ourselves.
So how does this feed into the animations? There we go.
A common pattern that I recommend is to do this. If anyone's done any Android work, you might have done something like create intent, a static method at the top of your activity, so that you keep all the extras and all those private names and variables inside the activity. This kind of keeps that encompassing class self-contained. And we're trying to do the same thing here. So basically we have a static route method that creates a route for us that returns this widget. So rather than having to write material page route builder this, which I see absolutely everywhere in every example, we just call workoutlist.page.route. So it's just hiding that complexity away, and it makes the code a lot cleaner to see when you go back. So as you can see down here, it's just nice and simple, and it makes a bit more sense. You can imagine you can just do push and then do workoutlist.page.route, and it makes way more sense. Scroll down.
Sure.
Scroll up a little bit. Where are we? Yeah, so this is a standard stateful widget. We pass in, we've got our state here, and here's that important single ticker provider state mixin. There you go, that's the name of it. And down here, we use a duration, and we specify the vsync as this. The reason why this works is because our mixin matches the interface for us. So from that, we get our controller. Now, if you notice, we don't specify an upper bound and lower bound on the controller. That defaults to 0 and 1. So basically 0%, 100%, standard stuff for animations. And then we're going to try and achieve this effect over here.
Which one do you want?
Just switch tabs and switch back again. So this animation as they all slide in, it's actually quite a big trick. We just surround each item in a padding, and then once it comes in, we just decrease the padding slowly, and of course they take up less room. Each one takes up less room, and you get that nice kind of transition as they're all coming in, without having to deal with scrolls or anything crazy, and scroll controllers and all the fun stuff there.
So you're animating the edge insets.
Yeah. So here we've done a edge insets geometry tween. This is one of the built-in tweens, and we can just specify two edge sets. You can see here we're going from 128 down to 0, and then we call the animate function. So every tween has an animate function, and that takes a parent animation as a parameter. In this case, we're specifying a curved animation. This allows us to parent on a deceleration. So this can be any one of the built-in curves. There's curves.ease in, ease out, and so on. And then the parent must be something that's going to... these are basically... It's the same as chaining something together. We're chaining our custom animation from our tween with a curved animation, and that's parented to the controller, which is actually controlling the entire animation itself. You can chain these in lots of different funky ways, including sequencing things and doing lots of fun stuff like that. We don't actually have an example, but there's documentation and examples online of using a interval as a curve parameter, and that allows you to specify what fraction of the animation is going to be played, this tween is going to be played in, for instance.
Okay, and now that you know how it's done, take a look at it again, since it's animating the padding with the edge insets, okay, on that deceleration curve. So, makes a little more sense when you know how it's done. What you want?
Yeah, scroll down a little bit further. So, because modal.root.of uses an inherited widget, we can't do it inside initialized state, so we do it inside did change dependencies. If you don't know, this function is called, this lifecycle function is called straight after init state, the first time the widget is created, and also any widget that is an inherited widget that you've registered to. Every time that's updated, it will call this function to rebuild the widget and adjust things. So in this case, we're doing modal root of context, .animation, add status listener, and this function here, which is down below. And all we're doing here is saying, once the animation is completed, turn on our animation going forward. So once we transition into the screen, then start our animation of all the items collapsing. So it's very subtle. If you go back and forward again, you see the top header came in first with Eero's picture.
Yes, that's Eero.
It's very subtle. It comes in as part of the material root, page root animation itself, and then the rest animates in. So you can imagine that you can sequence off quite a few different animations by using this simple animation add status listener, and then once it's finished transitioning into the screen, then starting your animations. The reason why this is kind of important is because your build function would have been called already. So you can't schedule anything in there. Your widget would have already been built and ready to be displayed on the screen. And not to forget, always clean up after yourself.
You haven't seen his office.
Thanks. So
I'm here for the comic relief.
So what we've got here, we've got a header and we've got each one of the items, and this is simply how we do the entire thing. So we create a blank child array when we get built, add our header, which is down below, and then for each item, we're creating one of those animated builders, and the animation it's listened to is that padding one that we created above, and every time that padding gets changed during the controller's duration, we're going to rebuild this. This function is going to get called and rebuild these two widgets, which is an opacity and a padding. So this allows them to fade and the padding to come in. And then down here, the child is passed in as this parameter here. And we're passing in our workout card with our tap listener. If you scroll down further. The entire screen is just a single child scroll view for simplicity purposes, but there's no reason why you couldn't use custom scroll view with slivers and all that fun stuff. I don't think anyone cares much about the implementation further down, but we'll just scroll through it slowly and see if there's anything steps out. Oh, there's one thing here. If no one's done this before, you can specify a color filter of black with an opacity with blend mode darken. And this allows you to get that effect where the image is darkened and the text stands out. Very simple line. Add that to any one of your images. You can use asset.image. It doesn't have to be a decoration image.
And in all seriousness, how many of you guys have beaten your head against a wall trying to get white text to show up on a picture and tried to figure out how to get your drop shadow to work properly in order to get it to stand out. This is a lifesaver.
Another little known widget. This was to give us 70% of the width so that the breaking of the text looks nice, goes onto 2 lines. I've just realized the title's the same on all of those. So we've got 70% width here. If you scroll down further, we use this, again, a little known widget called Spacer. It's basically just an expanded widget that fills up the top portion of the height of the card. And we've got some text. Simple enough. This is done as a stack, so when you get the touch effect goes over the top and still gets clipped. This is the dev branch, and there was a bug which I worked around with that. So, yeah, hopefully it won't be in the latest master. Scroll down a bit further.
You moved my cursor.
Yeah, so that's just that clip rect with a. If anyone's trying to do this, by the way, have a touch effect, touch ripple on top of an image. There's actually a proper widget to solve that problem, which is ink.image. Sadly, it doesn't clip the rounded corners, which is why I didn't use it. I'll submit a PR after the talk. The clip rect is good enough to clip a transparent material on top without inkwell, and this is just enough to get that touch effect on each one of the cards. This is just the standard header layout. Yeah, standard stuff. So once you tap on one of these cards, we're going to look at that transition. So that's very subtle. Do you want to tap back and forth?
Okay. Do we want to slow this down?
Yeah, let's do that. Oh, it has to be off the screen.
You want to use it?
You can do it. So if you guys don't know, if you use Flutter Inspector, there's a little cog in the top right here, and underneath that, enable slow animations. Very, very handy when you're doing transitions. Little hidden option. And now it's going to go slow. So again, there's a couple of different things going on.
Let me do it with the mouse.
We'll add some staggering and some other nice little things to this, but it's very subtle. So if you scroll this as well,
Okay.
you'll see.
Oh.
See the back fades as well. So the back actually faded in during the transition, but it's fading out when we scroll. So we're actually controlling the transparency of the back button using 2 animation values. And the rest will be filled in later. But this code is all going to be available. Let's just tackle the code.
One other thing real quick to point out. You guys notice that, okay, fine. We said in the example that it would hero in. This top image right here, you notice how it's not exactly heroing in, it's more transitioning in from the bottom. When he finishes the code out, he's going to leave that undone so you guys can muck about with it and get a feel for it. And it's kind of like a code lab where you get most of the code, but they still leave something to play with. So, where'd you?
Scroll back up to the clip list stuff.
Clip list.
There we go. So each item is given a lambda which completes to this on-tap workout with the workout option. And here you can see there's a good example of that, what we were talking about earlier, navigator of context. Now, interesting enough, if you notice, we're not actually using that navigation key because our page is within the parent navigator. We're actually getting that from doing this navigator of context, not the one that surrounds the entire app for us. And then we're pushing the detail page route, giving it the workout that we want to display for the details.
What do you want? Oh.
Life So here, again, the same pattern with a static root, and we're passing a workout parameter, which we pass on to the widget, which is a required named parameter. This is quite a nice pattern to use when you're trying to pass parameters into your top-level page widgets. Let's go down to the stack. Right, we're going to try and get through some of this. Should we show the animation again? Sure. So there's an interesting point here. We've got the bottom section coming up during the transition. And when you scroll, that whole section scrolls over the top of the header. We're going to see how that's done. So again, at the very beginning, we're going to get the modal root of the current context and the theme. We do a stack. So the entire page, contents is a stack. And underneath at the bottom of the stack, we have our workout header, which is this top section here. And then on top of that, we have this layout builder. This is so that we get the width and height of the page. So we can do this offsetted animation. As we were saying before, with creating animations, you can use a tween. At any point during your code, you don't have to do this using init state. In this case, we'd create a tween during our layout builder, going from constraints max height, so the entire height of the screen, and then constraints max width times 0.9. This is about getting a more or less square aspect ratio, so we get a nice little bit of an overlap on the image. And again, curved animation with a decelerate. Now here's the interesting point. We parent to the roots animation. So the inset itself, this tween, is animated during the roots transition into the screen and leaving the screen. And then we return an animated builder from our layout builder, and we're using that inset. Inset here is actually the animation from the tween, because we're calling that animate function. And we're monitoring that, and this function is going to, this widget here, the single child scroll, is the one that gets rebuilt as the transition actually happens. In this case, we're actually we're monitoring the scroll. We're passing a scroll controller over, and here we're specifying the top padding is the inset value. So that will go from being the maximum height of the screen to that sort of almost square fraction. And further down, again, this is the kind of interesting point. Child, too far. Go back up a bit. There we are. Child here is the this is the content that's not going to get rebuilt, which has the page content in it. So that is the rest of the content of the screen, and that's going to get passed straight in and not get rebuilt each time the animation parameter changes. In this case, we've got a container with a box decoration of the background with rounded corners. This gives us this little sort of rounded corners on the image on the bottom panel. And we set up a container with max height. This is just so that we can scroll it without the content being filled in yet. We call this function build page content, which is below. We'll come to that in a minute. Interesting point, the back icon up here needs to go below the status bar. So we just stick it at the top of the stack with safe area. And we're going to pass over the root animation and the scroll controller that we're using so we can fade it out nicely.
Okay. We've gone over a lot already and probably a bit more. Any questions to this point before you forget these questions because we go over more stuff? Everybody, are you so lost you don't even know what to ask?
Not that in one.
Scroll down a bit further. I won't go into this in detail. This is just this page content here. But there's a widget I've created that you guys can reuse, horizontal featured items, which allows you to do these kind of like page view type scrolling lists with using a viewport fraction, which is kind of handy. So this is saying that we want to have 2.5 views always on the screen. And then we can also pass in, if you scroll a bit further down, there's another optional parameter, aspect ratio, 70% in this case. So you can see these like panels. So this is like, you know, if you're trying to do one of these carousels, a nice little widget for you guys to steal. Take it, do whatever you want with it. Yes. Do we have something else? I think so. Oh yeah, the back button. Yeah. The back button at the top, we're passing in the scroll control and the root animation, and we're creating a animated builder based on listenable.merge. Again, underused function. This allows us to combine two listenables into one, so that the back icon is going to get rebuilt when either one of these notifies that it's been changed. And then inside our builder function, we're going to work out what the opacity should be based on the status of the root animation. So if it's been completed, then we're going to use the scroll offset based on 128 dip, and we're going to clamp it to 0 and 1 because opacity can't be less than 0 or greater than 1. Otherwise, we're using the root animation's completion as the opacity. So this allows us to fade in the back button during the root animation. And we just rebuild the opacity widget with the new value. This is just our back button again. This just does navigator of context pop, which is going to take us to the current navigator again, the one just for the page content, and that's going to pop off that and take us back to the list of workouts in this case. I think the workout header. This is just that header section that's behind. It's pretty much identical to what we've seen before. No more animation stuff in there. So there are some interesting points that have been covered in what we've done. If you notice that we've done quite a bit with animated builder. Again, animated builder, very powerful. I'd like to do an example of animated switcher, which will come up in this code when I publish it online, hopefully tomorrow. So, I think that's it.
And the only other thing I can think of is in the slides at one point. In fact, I do want to go back and make sure that I point at the right slide. In a tween, okay, you can, yes, you can tween lots of things. I'm sorry. So you can end up tweening a square to a circle, you know, all kinds of interesting things. I was just making sure that we touched on that. Okay, now questions. This is where we wait 30 seconds and someone finally gets brave.
We've got the one microphone, so.
It's not really a question. I was wondering, could you turn on GPU rendering bars for that animation? I don't know if Genymotion supports that. So in developer options, there's a profiling. No, on the device. So if you go to developer options on the emulator, if that's possible.
Okay.
I just wondered, so Flutter team says
There we go.
refresh is at 60 hertz. That's quite a nice animation. It does quite a lot of things. I wondered what the frame rate was.
Yeah, let's take a look at that.
It is in debug mode though as well, right? Oh, it's running in.
I'm not finding, where's developer options? It should be right here.
Presumably it still makes TP calls. So, yeah, but at the same time.
Yeah, I mean, I don't. Storage. Yeah, but it should have already been in developer, yeah? Oh, there we go.
And so you do get far smoother animations, and they recommend, the team recommends you only look at your animations in profile mode if you're working well. They have a dash profile mode as well, and I think you can even in the maybe the button isn't exposed, but you can like do run options, run profile, and that'll give you actually all the ability to even like Flutter itself has like a GPU profiler that it can overlay on the
GPU view update. I'm sorry, what was that setting?
settings, right?
Yeah, wondering about the GPU bars.
Flutter Inspector's GPU profiler.
Simon, and then Flutter Inspector as a GPU profiler should actually show how it renders. The icons on top.
That's giving you 100 frames per second, right?
Exactly. Yeah, that'll
That's
do
your break point there.
it. Yep.
This is debug.
Yeah, so
Mhm.
it would know if you
Debug on an emulator on a not all that expensive laptop.
I mean, there are ways to optimize a lot of these animations. It's something that we can look at in detail.
Well, I wondered about things like, you know, when so you've added a shade onto the image to reduce the contrast with text. I wondered whether that was recalculated all the time. Every
No,
frame.
so those elements are being reused. All of the display lists are being reused. So there shouldn't be any cost to the GPU for making those changes.
Cool.
It's done actually as a GPU shader, the color filters.
Oh, right, okay. So it's just the text map is being run through a shader that does the processing every frame. So if you want to
Yes,
animate-
so the color filter is actually passed across to the GPU as part of the canvas system.
Oh, okay. Right.
If anyone's actually interested, there are plenty of details that can be gone into in terms of how the system does its rendering, but I think that's a different
There's a
talk.
YouTube talk by Adam Barr from the Flutter team when he explains actually how it draws and how it actually recycles the elements which are actually not immutable, so all the tile views, and how it actually saves.
Yeah, I think that was that the mahogany staircase one. Was that one of the old? Is that the older one?
It is the older one. That's like a half an hour long. Yeah.
You said that's by Adam Barth.
Yeah.
We'll update some resources as some slides, and we'll publish the slides along with the GitHub link. Don't think they're on the slides at the moment, but we'll push them out on the Flutter community, and you guys can all subscribe up to that if you're not already subscribed.
And there are multiple Flutter communities. There's a Flutter community Facebook page, which is ours. There's a public Facebook group, which is not. There's Flutter community GitHub, which is where this is going. And there's also Flutter community Medium, which we run with Nash and Yaron. And Thomas, too, or on that one? I can never remember. We got too much going on. But,
If you guys are actually making apps, I highly recommend that you put up some screenshots on itsallwidgets.com.
Yes.
That's where we're trying to push the community-made applications.
That's it. All right, on.
Yeah, there you go.
Lastly, anyone have any last questions? Any general Flutter questions, not just related to tonight's presentations? Anybody?
I thought you were supposed to demo something else. One more thing sort of thing.
Yes.
I did show a few people last month something we've been working on.
I'm sorry, Jim Motion crashed. What a shame.
Hopefully this works.
Hey, you're late.
There we go. Slow computer. We've actually got DPI scaling, I think, turned on this.
Now, I had talked about this a little bit earlier. This is the one that I use for.
So this is actually using the Flutter engine on Windows. It's actually a debug build, so ignore the flickering. That wouldn't be there on the release. But this is kind of interesting because we're working on building a simulator. So the idea is that you'll be able to make your Flutter apps. This is done in C#, so it should compile for Mac and Linux. Fingers crossed. But the idea being that rather than having to use a heavy emulator or real device, you can do instant hot reload and hot restart straight to the simulator. And this eats up about 200 meg of RAM and about less than 5% of your CPU, so considerably less than emulator.
And I want to be very clear. The hot reload and hot restart, we need to start digging into that. They are not available right now.
I've also been looking into doing window Chrome, and that there's actually events that are getting sent from the simulator to the platform, and you guys can, if you want, hook into minimize and know when the app's being minimized or maximized and that kind of fun stuff.
This particular app, as you can see, it says that we're in portrait mode and using set state. For Beyond Hello World, a talk that I did a little while ago, I made 2 different UIs. And what I did was I had it start from main, and depending on which orientation, it branched. And it would use set state or scope model. And then it would turn around and call the same UI content page and just pass in whatever the values are. So it basically split and then back again. And they do maintain their states separately.
So if you didn't see that, it's changed the title to landscape page. If you guys don't realize, landscape and portrait is just basically is the width taller than, is the width wider than the height.
It does that if you start jerking it around a bit too much, it does protest.
This is actually early prototype, earlier than the one we actually have. So.
Yeah, that's true. This is about a month old. So, oh no, we took it off. I'm sorry. We thought we were finished.
Oh, that's right. Never mind.
Okay. Okay, now that I haven't been on the video for about 10 minutes, this is a demonstration app that was used. We're in portrait mode right now using set state. It does maintain its state. Landscape, that widget uses scope model. Now there is one interesting thing you notice when we are changing the window size. The orientation builder is just looking at what's longer, height or width. And that's how it's determining landscape and portrait. An interesting thing that we found out accidentally is that as you transition through, the orientation builder apparently is flipping many, many times when it gets to a point where it's square. And the reason that we know this is that this code right here will go through a number of different text. It will say a number of different things. And the last of which, okay, is Houston, you have a personal problem. Okay, and now a number of times rotated, I started to debug this issue. And it will show you the actual version here in just a moment. But for some strange reason, when you pass through where it's square, I'm going to hook that up and count the number of times rotated. I got interrupted. Not by you, I'm sorry. I mean, I got interrupted while I was setting that up, and that's why it's just saying rotated once. But I do wonder what number I'm going to come up with, whether it's 10 or 20 or 1,000. It's not the world's fastest computer. I don't either. Oh, wrong one. Yeah, it's the one with the Flutter icon, right? Well, there's the problem. You've got too much crap running. You should see my girlfriend. She has like 50 WAPs running. Actually, yeah, that's okay. I mean, it's a detail, but it goes through a number of things. But I can show you the little bit of fun code real quick before we take off. Yeah, it's fine. Do it in this window. What it's doing, not that one. There are a couple of projects in here. in the main, what we're doing here is we're going to double check and see if the scoped model, the model has a value called you broke it. If the scope model count goes over 110, it flips that flag. So what we're doing here is the orientation builder checks it. If the counter is broken, return you broke it, and then add another message. If it is not broken, you go down here and you say, is orientation portrait? If so, return the portrait page widget, else return the landscape. But the fun happens if it's broken, because the first page says, you broke it. No, man, you seriously messed it up bad. Okay, are you having fun? And then the last one is, Houston, you have a personal problem. It's kind of fun when you're flipping it back and forth, and 4 times it keeps changing, but it really ruins it when it just jumps to the last one. So, as usual, I got to fix something on Windows in order to be able to get everything else to work. Anything else? Oh, actually, how about how that works within the C# file? What's it actually doing when it makes the window?
We'll do a different. I think I haven't got the code with me, so we'll do a different talk about that. But it basically, this is using the Flutter engine embedder, which is the desktop embedder, as the fundamental basis, and then we render it with OpenGL and all that fun stuff. Code will be available shortly.